lateral prefrontal cortex and self-control, and intertemporal choice.
Every day we make decisions that trade off short-term and long-term consequences. In such intemporal choices between sooner smaller and later larger rewards, humans and other animals exhibit impatience, particularly if immediate rewards are available. Steep discounting of delayed rewards has been implicated in suboptimal behaviors such as insufficient saving for retirement, substance abuse, and non-response to climate change. The neural basis of intemporal choice is still intensively debated, with 3 recent neural accounts: single valuation, dual valuation, and self-control. The first 2 reflect important functional magnetic resonance imaging studies of intemporal choice. The third is based only on indirect evidence of intemporal choice. The third is based only on indirect evidence from functional magnetic resonance imaging and RTMS studies. To the best of our knowledge, no study has provided causal evidence to investigate self-control mechanisms in intemporal choice.
The 3 accounts mostly agree on brain regions involve ventral striatum, medial prefrontal cortex, posterior cingulate cortex, and lateral prefrontal cortex, but differ substantially on specifics. Both the single and dual valuation accounts assume that the choice of an option is a direct result of the comparison of their valuations, without additional intervening processes such as self-control. In contrast, the self-control account assumes that the tempting option, an immediate sooner smaller reward, may be valued more highly than an alternative, a delayed later larger reward, but that the later larger reward must still be chosen as a result of intervening self-control process. The dorsolateral prefrontal cortex has been implicated in self-control, making it a prime target for a brain stimulation study.
Transient disruption of LPFC with RTMS therefore provides a crucial test for the need of a self-control component in intemporal choice models. Both dual and single valuation accounts predict that whatever effect LPFC disruption might have on choice should be reflected in option valuations, as choice follows directly from valuation. In contrast, the self-control account predicts that choice can be influenced without altering valuation.
What is the experiment overview is shown as this figure. Participants completed the choice task, valuation task, and the choice titration task twice. One immediately after RTMS training and the second time 30 minutes after the RTMS training. Task 1 is a choice task containing 36 binary choices between sooner smaller and later larger options. 18 now trials with immediate sooner smaller rewards and later larger rewards in 2 weeks. 18 not now trials contain both delayed sooner smaller and later larger rewards in 2 and 4 weeks respectively. The relative differences in sooner smaller and later larger magnitudes ranging from small to large. On each trial, participants were presented simultaneously with the sooner smaller and the later larger rewards on a computer screen, and expressed their choice by clicking on the radio button below their preferred option. Trials were presented in 6 different pseudo-random orders, counterbalanced across left RTMS versus right RTMS versus sham groups. And there are also 2 task administrations containing immediately after RTMS training versus 30 minutes after RTMS training. Completion of the choice task took on average 3 minutes, and there were no significant differences in completion time between RTMS groups. The second task is a valuation task that was administered right after the choice task. Participants were asked to rate attractiveness of 12 single options that each provided a specific amount of money at a specified time point. The options were taken from the choice task, reflecting the 4 time points of delivery: today, in 2 weeks, in 4 weeks, and in 6 weeks, crossed with 3 levels of reward magnitude: low CHF 30, medium CHF 45, and large CHF 60. Valuation ratings were made on a continuous visual analog scale, with endpoints very unattractive and very attractive. Completion of the valuation task took on average 1 minute, and there were no significant differences in completion time between RTMS groups. The third task is a choice titration task containing 2 trials. It was administered right after the evaluation task. In the first trial, participants made a series of binary choices between a constant soonest smaller reward of CHF 50 per day versus a variable later larger reward with a 3 months delay. The later larger reward increased in steps of 5, starting with CHF 555 and ending up with CHF 105. The dependent measure was the switching point, where the amount of the later larger reward at which participants switched from the soonest smaller to the later larger. In the second trial, participants were presented choices between a constant soonest smaller reward of CHF 30 in 2 months and a later larger reward delivered in 5 months. The amount of later larger reward ranged from CHF 35 to 85 in steps of 5. This choice titration task provided us with more evidence to rule out the possibility that finding no differences between RTMS groups in the evaluation task was the result of the effect of RTMS having worn off, since the RTMS effect was still in place in the subsequent titration task.
To test for the LPFC's involvement in intertemporal self-control processes, we applied to each of 52 participants a 15-minute train of 1 Hz low-frequency RTMS to either the left or right LPFC or sham RTMS. Participants completed 3 tasks. The first was a choice task of 36 binary choices between sooner, smaller, and later, larger option, with the relative differences in sooner, smaller, later, larger magnitudes ranging from small to large. The second was a evaluation task, in which participants rated the attractiveness of 12 single options taken from the choice set. The third was a choice titration task. Each task was administered twice, immediately after the RTMS train, and again 30 minutes later, after RTMS effects were expected to have dissipated. We compared data both between the RTMS groups and within groups across the 2 task administrations,
as they are particularly tempting and require the most self-control, most strongly for intermediate relative differences, as subjective discounted values of sooner smaller and later larger are close, resulting in increased temptation and choice conflict. We found significant differences for left versus sham and left versus right groups for now trials of TA1. All other comparisons were non-significant. Groups comparison was replicated by a within-groups comparison. In addition, both analyses indicated that the left RTMS effects in TA1 were significantly stronger for now than for not now trials. As expected, the RTMS effect was particularly strong for now trials with intermediate relative differences in reward magnitudes. The left RTMS effects in TA1 now trials were significantly stronger for intermediate than for small and large relative differences, as confirmed by both the within and between comparisons. In contrast, valuations of single options showed no effect of either RTMS or task administration in both analyses. However, valuation showed the same sensitivity to the reward magnitude and time of delivery. Because of the independence of valuation from the effects of RTMS is crucial for the self-control account, we conducted follow-up analyses to corroborate these results and rule out alternative explanations, such as lower diagnostic sensitivity or statistical power of the valuation task and decay of the RTMS effect.
Finally, we examined reversals between the preference implicit in the valuation task and the choices in TA1 now trials. The 2 valuation accounts predict no systematic preference reversals between valuations and choices. The self-control account predicts that intact self-control leads to increased number of self-controlled preference reversals in which the later larger reward is chosen, although the immediate sooner smaller reward is valued more highly. Impaired self-control produced an increase in impulsive preference reversals were consistent with self-control predictions. Impulsive preference reversals. In summary, we found that transient disruption of the left but not right LPFC by RTMs led to increased chosen of immediately available rewards. No effects were found for trials involving only delayed rewards or 30 minutes after RTMs, when RTM's effect had worn off. In contrast, no effects were found for valuation. We also found a twofold preference reversals pattern of differences in self-controlled and impulsive preference reversals that was predicted by the self-control account.
Taken together, our results indicate that the left lateral prefrontal cortex is a crucial neural substrate for self-control processes and intertemporal choice. Our results are consistent with several possible neural implementations of how the LPFC exerts self-control and intertemporal choice, which should be investigated in the future. Possible implementations might work via the modulation of activity in valuation regions, via input into valuation areas, via different influence of attention given to magnitude versus timing of rewards, or via a more direct influence on choice, such as the inhibition of a prepotent response. Regardless of their neural implementation, our results provide, to the best of our knowledge, the first causal evidence that self-control processes should be incorporated into existing neural models of intertemporal choice.